The official definition of related rates involves finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. This rate of change is usually taken with respect to time.
This generally means to use quantities and rates in the problem to find unknown rates.
A good system for solving related rates problems can be remembered using the acronym DREADS. The first thing you'll want to do is draw a diagram to help you visualize the problem. In this diagram, you'll want to label your rates of change as well as your variables.
The next step in DREADS is the R, which stands for rates. In this step, you'll want to list your variables and rates of change that you will need for the problem.
Next, you'll want to write an equation that relates all of the variables in the problem.
Then you'll want to take the derivative of the equation with respect to time.
Finally, substitute and simplify. You'll want to insert the known rates and variables into the derivative equation and solve for the unknown rate.
An example of an all-American related rates problem is a ladder which is 25 feet long is leaning against a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. How fast is the top of the ladder moving down the wall when the ladder's base is 15 feet from the wall?
For our first step in DREADS, we will draw a diagram with our variables labeled. In the problem, it's given that x is 15 feet and that z is 25 feet. The value for y is not given in the problem, so we will be able to use the Pythagorean theorem to find this value. So the value for y ends up being 20 feet.
Next, you will want to label your rates of change. dz dt is going to be 0 feet per second since the length of the ladder is not changing. dy dt is going to have a question mark since this is the rate we are trying to find, and dx dt is going to be 2 feet per second. Next, you'll want to write your rates off to the side to help organize your work.
Your x is going to be 15, your y is going to be 20, your z will be 25, the dx dt value will be 2 feet per second, the dy dt value is what we're trying to find, so we'll circle it in red, and the dz dt value will be 0 feet per second. Next, you'll want to write an equation that relates all of your variables. In this case, the equation x squared plus y squared equals z squared will be appropriate. Next, you'll want to take the derivative of this equation with respect to time, giving us 2x dx dt plus 2y dy dt equals 2z dz dt.
Now all that's left to do is substitute in the values for our variables and rates of change and simplify to solve for dy dt. Substitute 15 for x, 20 for y, and 25 for z. 2 for dx dt, nothing for dy dt as that is what we are finding, and 0 for dz dt. Now we can simplify and solve for our variable dy dt, which ends up being negative 3 over 2 feet per second. The value is negative as the ladder is sliding down the wall. This means that the ladder is sliding down the wall at a rate of negative 3 over 2 feet per second when the base of the ladder is 15 feet from the wall.
We hope you found this video helpful in enhancing your knowledge of related rates. For additional practice, we have a worksheet with 4 example problems with their solutions outlined in videos also on this site. Thank you for watching, and
hope you found this howdy helpful.